Hello everyone, good day. Today, we are going to tackle about ethnomathematics. But before we start, let us introduce ourselves. I am Joane Paula V. Villalon, or you can call me Miss Joane.
And as for myself, I am Prencess Ann Sarong, though you can call me Miss Ann.
And I am Genevive Labeta. I hope everyone has a good day today.
What is ethnomathematics? Ethnomathematics, it is the mathematics that is persistent in particular cultural group. It is derived from ethnos, within cultural background, and mathema, explaining and understanding in order to transcend, managing and coping with reality in order to survive and strive, and takes or techniques such as counting, ordering, sorting, measuring, weighting, ciphering, classifying, interfering, and modeling.
As you might imagine, the development of a base system is an important step in making the counting process more efficient. Our own base 10 system probably arose from the fact that we have 10 fingers and 2 hands. This is a natural development. However, other civilizations have had a variety of bases under than 10. For example, the Native Americans used binary in counting, a numeral system with 5 as the base. On the other hand, the Mesoamerican used the vigesimal number system, a system based on 20. This counting system required only 3 symbols, a dot representing a value of 1, a bar representing 5, and a shell representing 0. Just like the Mesoamerican, the Mayans also used the vigesimal number system. Those 3 symbols were used in various combinations to keep track of calendar events, both past and present. They have the Dresden Codex, the earliest surviving book written in the Americas. In the absence of an alphabetic writing system, simple and high portable device achieved a surprising degree of precision and flexibility. The Incas relied on quipus to keep records of the extended empire. While the quipus stored numbers, the actual counting was presumably done using the yopana, the Incan abacus. In addition to this, Africans used words for certain numbers that are based upon the parts of the human body.
You know what is kepo? Kepo were knotted tally cords used by Inca civilizations of South America. The system consisted of a main cord, from which a variable number of pendant cords were attached. These knots and their cluster conveyed a numerical information. Think of it as a quipu. This quipu, it may look like this, but it conveyed a numerical information. The number, type of knots, the knots and cluster spacing, as well as the pendant array, all conveyed particular information. Let me show you a picture right here of what a capo looks like and what is the number conveyed each. As you can see, that is how the Inca civilization used to convey a numerical information. Let us proceed to our next topic, which is Mayan numeral system, vigesimal or base 20 numeral system. What is Mayan numeral system? It is a mathematical efficient numeral system was devised by the early Maya people of Mesoamerica. Mayan numeral system or vigesimal system is base 20. It's positionally and possess a 0 placeholder. So the Mayan numeral system starts with 0 and ends with 19. That is what a base 20. And now, let me show you how to write the following numbers in Mayan numeral system, and I will explain to you how to do it. Let me ask you first, what is the base of Mayan numeral system? So, 20. We use the base 20 for us to identify how we are going to write the numbers beyond 19. Let me show you the process following numbers in Mayan numeral system. 3,446. We need to write it in Mayan numeral system. First thing to do is we need to use the base 20 and we need to find an exponent that will not exceed the number 3,446. We use 20 raised to the power of 3 is equivalent of 8,000. So it exceeded the number 3,446. Let us try the exponent 2. 20 squared is equivalent of 400. Need to divide the 3,446 to 400 is equals 8. Write the number 8 right here, and 8 times 20 squared is equals 3,200. Then, the 3,200, we will subtract it to 3,446 for us to get the remaining number so that we can proceed. We have remaining 246. And let us continue the process. 20 raised to the power of 1 is equivalent to 20. We need to divide 246 divided by 20 is equals 12. 12 times 20 is equals to 240. 246 minus 240 is equals 6. So we have the remaining 6. We need to copy the remaining number because an exponent or a number exponent by 0 is equals to 1, equivalent to the number na nabilin. This is it. 3,200 plus 240 is equals to 3,440 plus 6 is equals 3,446. And that's it. That is how we write the numbers in Mayan numeral system.
For example, we have 52,124 as the Hindu-Arabic numeral. In this example, we will use 3 as the highest power of 20 since we cannot use 4 because it will exceed our chosen number. 20 raised to the power of 3 is 8,000. Then 52,124 divided by 8,000 is 6. Therefore, our first term, 6 times 20 cubed equals 48,000. In Mayan symbols, it's a dot on the line. 52,124 minus 48,000 is 4,124, which will be our current number. In the second line, it's 20 raised to the power of 2. The answer is 400. Our current number is 4,124. Let's divide it by 400. It will be 10. 10 times 20 squared equals 4,000. In Mayan, it's a 2 lines, and the process continues. The third term will be 6 multiplied by 20, which results to 120. Symbols are a dot on the line. The last will be 4 multiplied by 20 to the power of 0 equals 4. With a symbol of our dot, if we will add all the results, it will be equal to 52,124.
So we have here 3,548. To transcribe this, we have to use the base 20. So we'll write down 20 and we'll find a number that doesn't exceed to 3,548. So we'll multiply 20 to itself. For example, 20 squared equals to 400. As you can see, it doesn't exceed to 3,548. We'll now try another example, like 20 cubed. We'll try to calculate 20 cubed, and it equals to 8,000. And as you can see, that it exceeds to 3,548. Therefore, we'll use 20 squared. So we'll write down 20 squared, and then we'll divide 20 squared or 400 from 3,548. The product should be 8. So we'll write down 8 and then multiply it to 400. The product should be 3,200. After the 20 exponent to 2, we'll proceed to 20 exponent to 1. Same process, but we're gonna subtract 3,200 from 3,548. The product should be 348. Then you have to divide 348 divided by 20. That is the 20 exponent 1. So the product of 20 divided by 348 should be 17. And then you're going to multiply 17 times 20. The product should be 340. So we'll proceed now. After 1, it should be 0. So we'll write down 20 exponent to 0. But we should take note that any exponent with 0 is equivalent to 1. Same process, from subtracting 3,200 from 3,548, we should get 348. Then 348 minus 340, that should be 8. Then 8 multiplied to 20 exponent to 0, but it is 1, right? So it should be 8 times 1 equals 8. And then we'll use the vigesimal or base 20 numerical system. So starting from 8, it should be 3 dots and 1 horizontal line. In 17, it should be 2 dots and 3 horizontal lines. And in 8, it should be 3 dots and 1 horizontal line. To make sure that your answer is correct, we need to sum them up. So 3,200 plus 340 plus 8 equals 3,548.
That's it then. I hope this video has taught you something.
We hope that you learned something from the ethnomathematics.
We appreciate your time and we hope you acquire some valuable lesson and accomplish more. Thank you.